Hello and welcome to Write Once, Run Anywhere, hybrid progressive web apps with Ionic and the ArcGIS API for JavaScript. My name is Kevin Kelchin. I work at Cartograph, and this talk was originally slated to be given at the 2020 Esri Dev Summit. However, due to the spread of the coronavirus, it was canceled. I've decided to go ahead and give my talk as a pre-recorded talk because I feel that this message might still be valuable to someone. With the change in format, I am able to include some extra content that wouldn't otherwise have been able to fit in my Dev Summit session. This talk is not an intro of how to get started with Ionic or progressive web apps or integrating the ArcGIS API for JavaScript with them. There will be little in the way of steps, not very much code. Things are going to remain at a somewhat higher level, and we're going to be focusing on platform and other considerations that are important when using the Ionic tech stack. We'll be looking a little at an Ionic sample project that is on GitHub, and I'll share a link to that at the end. I want to take you on a journey of one of the greatest success stories we have had in bringing a product to market here at Cartograph. And the most appropriate place to start with that is with the individuals whose experiences and feelings matter most to us, and that is our users. Most of our clients are local governments. Those local governments are responsible for maintaining their infrastructure. That would be their roads, their signs, their bridges, things above and below ground, you name it. Those who actually go out and do the work with those assets are the field workers. Those field workers need to be able to understand what needs to be done, what are my tasks, where are these assets, these roads and signs located. They need spatial GIS data to be able to find that. They need to be able to get data about those assets. They need to enter data about those assets as they're installing them, as they're inspecting them, repairing them, replacing them. And so they need a mobile solution that allows them to be more efficient and effective in their work. And that's where Cartograph comes into play as we develop mobile applications for them. So our story begins. You're going to see a number of Princess Bride gifs. I'm warning you because I love that movie and it's what I was watching when I sort of started working on this. So first, let's go back in time. It's 2016. We determined that we need a phone app for our users. We don't have one. Looking at the existing landscape of our client apps, we have a desktop app. It's a single-page web application, and it was designed specifically with the form factor of the desktop in mind. It was not designed to be responsive to work on a phone. And we also thought, there are newer technologies out there, and from an architecture standpoint, some other options might be more interesting. We have a tablet app. It's for iOS. It's iPad only. It too is not responsive and was designed not to run on a phone's form factor. It uses Xamarin, which is C#.NET. We use that on the back end, and so it seemed like a good fit. We designed the app from the outset and architected it to try to have maximum code sharing in case we wanted to create an Android version, but we had learned when we started Android that there was enough code there that needed to be duplicated between platforms, that project didn't quite have the ROI that we wanted, so we didn't proceed with that. And so it just remained an iPad app. So what about the new phone app? By the way, this phone app is supposed to be responsive and work on a tablet as well. It's supposed to run on iOS. It's supposed to run on Android. So what technology were we going to use to build this? Well, we considered Xamarin. Why Xamarin? Well, because in addition to the reasons that I had mentioned before, Xamarin Forms was just starting to come out around this time, and that promised actual cross-platform UI, sharing UI elements across Android and iOS. However, as we looked a little closer at it, we learned that it was really designed for forms, which, although an important part of our type of application, it's just the forms. It's not all the other UI that we like to have. We really value user experience and creating custom UI to help craft the vision that we have. And that was going to require a lot of native code that was not going to be able to be shared. Because there wasn't going to be as much code sharing as we would like, we even considered full-on native, Swift or Objective-C in Java, and embracing separate UI frameworks and writing everything twice. However, that notion was not sitting the best with us because we thought, well, having to write features 2 times and fix bugs 2 times and to maintain 2 whole separate code bases that are really trying to do the same thing, there's got to be something better out there. And so we also looked at Ionic. Ionic is a framework and a tool set that allows you to create your application using web technology. It allows you to design your UI using HTML, CSS, and JavaScript. And as many are probably accustomed to when designing web apps, they can run cross-platform in different browsers and share all that UI code, and that same idea can be applied to mobile. We had a group of individuals, developers who were very familiar with web development at this time, and so it was a lot less to learn. We could reuse our skills and our knowledge of leading practices and design. And so as we looked at it and looked at the performance and the UX that we'd be able to get out of it, we ultimately chose Ionic. So let's talk about the Ionic tech stack. What is involved in this? Let's start with the top layer. That would be the framework layer. Ionic framework works first class with Angular and React. However, this React is not React Native. It's not React Native Web. It is actually React DOM. It is the same React that you use when you develop normal web applications. It is DOM native. It uses HTML and CSS. It uses the web platform and the browser APIs that you might be familiar with. How does this happen? It runs in a web view. A web view is basically a full screen web browser in a native app shell. And that's how these things are able to run. On iOS, it uses Safari or WebKit, you can think of it as. And on Android, it basically uses Chrome for Android. So you're looking at Safari, WebKit, Chrome, Chromium, and those are sort of the 2 browsers that you need to support. Vue.js support is coming to Ionic, but it's only in beta. They're waiting for Vue 3 to stabilize. What did we choose? We chose Angular. Now, Angular was the only choice at the time. However, we've been happy with that choice. It gives us modern component architecture, a great router, dependency injection, forms, a CLI for a prepackaged build system, running unit tests, TypeScript support, lots of batteries included out of the box. Works really well for larger enterprise applications, and Angular has treated us pretty well. Next, let's talk about Ionic, specifically Ionic framework. Now, Ionic has different components involved in it. It works a little bit with the framework layer above as far as tying into the routers. It works a little bit with the native layer below, but by and large, when we're talking about Ionic here at this layer, it is the ready-made library of reusable components. So let's take a look at some of these UI components that you can use in Ionic apps that are cross-platform and they run on the web. They don't require any native code or native plugins. In fact, the demos that I will show are running in a desktop browser. It has action sheets, alerts, sliding items with actions that are invocable by gestures, menus, modals, pickers, popovers, range controls, toggles, pull to refresh, skeleton text for loading placeholders, reorderable items, segments, and toast messages, and many more. These components look native, they feel native, they're touch first, and they require no native code, and they're cross-platform. They're built on native web components, they're technically framework agnostic, they're lazy loaded, and they run fast. They're mobile optimized for touch and gestures, and they adapt to platform styling. On iOS, they look like iOS native components. On Android, it uses material design. You can customize them with native CSS variables, you can theme them, they're great. They give you a lot of building blocks that allow you to make more complicated UIs without having to invent the wheel from scratch. For the level below, the native layer, Ionic has a CLI, and that CLI can call the native layer. It can also call the Angular CLI as well. It wraps that to invoke build commands and such. And let's talk about that native layer that comes next. So the bridge layer between the web and the native is Cordova and Capacitor. So here you have another choice, Cordova or Capacitor. What they both do is they create and configure a native project. They wrap the native web view and provide it, that full screen web browser, and allow you to create and use plugins. And those plugins allow you to call a TypeScript or JavaScript function that ends up calling into native code to do something. So for example, SQLite is not something available in the browser. In JavaScript, I can run a SQL query and it hits a real native SQLite database and gives me my results back. It's like having the addition of non-standard JavaScript APIs that are native and device exclusive available to you. Cordova was formerly known as PhoneGap. It's been around quite a while. It's very mature. It has lots of plugins for various functionality. Chances are if there's something that you want to do that's native and not accessible via web APIs, there's probably a plugin out there for it. One of the downsides about Cordova is that it provides an abstraction layer around the native platform targets. This means that if you want to configure something, you need to go through both the Cordova layer and make sure that there's a hook or a spot that's carved out for you, an extension point, to be able to do whatever you want and configure in the native project before it gets down to that native level where it's iOS or Android. Sometimes that can be challenging if there's something that you're trying to work around, something quick that you're trying to do. You have to go through that Cordova layer. The native projects in Cordova are not source control artifacts. They don't get checked in to Git. They get generated on the fly. Capacitor, on the other hand, was created by Ionic. It just came out last year. And Ionic wants to own more of the native layer as part of their stack. And so they're creating this, and the philosophy is a little bit different behind it. Besides it being more modern, the native projects are source control artifacts. There isn't the black box abstraction layer to try to configure the native projects. You directly go into Xcode and configure your info plist or whatever it is to configure your native project settings, and for Android, Android Studio with the manifest XML or whatever, and you can do it like native developers do it. And that reduces a lot of the complexity that's involved in the tooling and embraces that these are, in the end, native projects. This has become the new Ionic default native layer for projects. They're still going to continue to support Cordova for years and years, but Capacitor is sort of the new way forward. So that's the Ionic tech stack. let's talk a little bit about who might be using Ionic. If you look at this, this comes from appfigures.com. They do SDK analysis of native apps in the stores. And if you look at the App Store on the left, Google Play on the right, Ionic has about 10% usage in the apps that are in the store. Now, it's not terrible. It's more than React Native right now. Cordova, if you spot that, probably a lot of those Ionic apps are also Cordova apps. But when you look at these numbers, probably about a third of the apps in both stores are using web technology, web UI, and that's even excluding React Native, that in the end uses native UI. But for actual web UI applications, about a third of the apps in the store. Apps like SwareKit, Untapped, and MarketWatch also use Ionic. We've never built an app faster when we used this technology. It was a matter of several months, and we had a greatly featured minimum viable product out there. We were still able to implement good patterns and practices and everything else, and there are other elements that helped us in our success, but the tools here allowed us to do great things in a short amount of time. So we got the deployment targets that we wanted and the platforms that we wanted, phone and tablet on iOS and Android. However, there is another deployment target that we are able to easily hit with the use of Ionic, and that is desktop. We're able to target desktop as a progressive web app, the desktop web, and that is because 99% of our application is HTML, CSS, and JavaScript. Again, it basically runs in a full-screen browser as a packaged native app. And so you can deploy that and host it as a web app. And you use progressive enhancement and things of that nature to handle the cases where you might not have the native APIs, but like 99% of most apps probably are using web technology only and web APIs only, and it can work. So, and it not only can run on desktop web, but the app's already responsive and works well on those mobile browsers, basically Safari and Chrome. And so you can use those mobile browsers on mobile devices if you don't want to have people that have to go through the app stores to get them. So you can target all these platforms in these ways. And in a way, you can say that this is write once, run anywhere. It is a single code base, and you can target all of these platforms, which is pretty amazing. Now, you might say that is inconceivable, but trust me, it's a conceivable thing. Conceive it. It's pretty amazing. One of the key takeaways here is that web technology today is at a point where with the tools, the browsers, the operating systems, the devices, you can develop a beautiful native-like application using web technology and do all the wonderful ArcGIS mapping that you want in that stack with a single code base that targets all these platforms. Progressive web apps, let's talk about that a little bit. What does that actually mean? Because not everyone might be familiar with progressive web apps. So there's no official definition of what a progressive web app is, so this is my definition. Using modern capabilities of the web platform with progressive enhancement to deliver native app-like experiences. So the web platform and browsers are growing more and more native-like APIs, and progressive enhancement is making sure that your application works as well as it can in browsers or on devices where they might not have all the APIs. And so you try to have fallbacks or what have you to still have a functional quality application, even if some of those APIs aren't there. So you're doing things like feature detection and so forth. But really, in developing these native app-like experiences, this is really a progressive web app is a web app. It's a web app with some optimizations and prioritizations of ways that you design your application. It can be added to an existing web app to make it a progressive web app, but it's probably easier to design it from the ground up. So here are sort of my core criteria for what makes a progressive web app. One is it's served over SSL. You need to serve it over SSL in order to even have some of these APIs be available for privacy and snooping reasons. The UX has a native feel and it's responsive. You're designing your app to not feel janky. You're doing good performance techniques, animations, and things are running at 60 frames per second. You're using native and gesture and touch-centric type paradigms to make sure that it does feel like a native app. It needs to load fast. It needs to be responsive when you're interacting with it. And you can do that with the technology that's there today. It loads offline. Well, what does that mean? Well, think of a native app. You download from the app stores the native binary. It might be very big, but that native binary has all the application code that it needs to run. It's got all the assemblies and artifacts and things that come out of your build process, and those get downloaded onto the device. So all the code is there to be able to run without an internet connection. Now, the app might not be super useful if you don't have an internet connection, but all the code is there to be able to run, display cached data, to operate otherwise. And so there are web APIs that allow you to download the static assets of the application, the HTML files, the JavaScript files, the CSS files, the images, the font files, the icons, all the things that you need code-wise to make the application run. You can do that on the web today. You can download those things, have them stored offline, and start up the app, and your code's there, and it actually runs instead of trying to go over the internet to download those resources. And then related to that, it's installable. The application can be installed, if you will, on your device, and it appears alongside all the other applications on your device. So let's take a look at a sample app. This is the Ionic Angular PWA demo. It's using the ArcGIS API for JavaScript 4x. This will be linked to on GitHub at the end of the presentation. This recording was taken on an iPhone 7 with iOS 13 Safari. So what we're going to do here is we're going to open Safari, and boom, it loads fast. So this is our application. It has a home screen here, which has a map on it, and it's got a couple of buttons on the top right, Detail and Modal. So if we go ahead and tap Modal, a modal overlay comes up. So now we have two maps, one on top of the other. And this modal is provided by Ionic. It uses the iOS 13 style modals with swipe to dismiss. And that's pretty sweet to be able to get that for free. You can also click the detail link, and you can go back and forth, navigate between the detail screen and the home screen. Now this is client-side routing with the Angular router. When you navigate between them, the screen that you're navigating away from is destroyed, and that's the only screen that exists. On the detail screen, you can also open up a modal. We have it there as well, using a different map type. Again, you can use the swipe to dismiss. Now that we're back on the home screen, we're going to click the browser share button, and that's going to bring up the native share dialog. And so that comes up. And the thing that we're going to click is Add to Home Screen. So we click Add to Home Screen. It has an application icon, an app name. This is configurable for your application, wherever you want it to be. I just left it be the defaults. So we'll hit Add, and there you go. It's on our home screen. We can tap it, and it launches. And the difference that you'll see here is that it's full screen. There's no browser Chrome. There's no URL bar or navigation buttons. It looks like a native app and does the things that you would expect. The modal opens, and again, it looks just like native. When you double tap the home button in the app switcher, you can see that the application's icon, its name, shows up above the app just like it does native apps like Safari. When we go ahead and dismiss the apps, let's try something new. Let's turn off our Wi-Fi and try opening up our app again. All right, so we get a message that comes up, and really what this message means is that it's not able to load the JavaScript API from Esri CDN, because we don't have that cache locally for offline or anything. This is a really simple example. So we'll dismiss the dialog, but look at what you see here behind this dialog. There's our toolbar at the top. We can navigate to the details screen and back. Routing works. JavaScript is working. Our application is working despite having no internet connection. And so that's the power of these progressive web app APIs. Taking a look at what the experience is like on Android, one difference is in Chrome for Android, the browser Chrome at the top, where the URL is, that's something that you can color. You can theme it to be whatever you want, whatever it fits best with your app. This is just the default Angular blue. And when you use the app, if you look toward the bottom there is a prompt to add the app to your home screen. And that's pretty cool. iOS doesn't have that, but Android does. So if we go ahead and tap the link down there to add it to the home screen and we hit add, it will install the app. Once it's installed, it appears on the home screen. When we launch it, a splash screen will show. There it is. It shows the app icon and name, and there you go, the full screen experience right here in Android. And there's the app icon and the app switcher as well. So this was using the Pixel 2 on Android 10. But when you see these things, you might want to say, I can't believe it's not native with these awesome APIs that we have. And beyond that, I mean, at this point, you might be feeling pretty good about things in terms of what capabilities are there. There are other APIs on the web that are able to tap into native functionality, and you don't need a plugin or anything else of that nature. However, before you decide to go all in on PWAs, supporting multiple platforms, so that you don't find yourself possibly unemployed in Greenland, let's take a look at some of these exciting APIs, but also some drawbacks. The thing is, these APIs can access native features, but they may be limited by the browser vendor and the platform. One of the great ways to be able to get an initial check of what's supported on a given device is to check out what web can do today. And what web can do today is a site that you visit on the device in the browser that you want to test for features. If you're familiar with caniuse.com for seeing what browsers and what platforms support what web API features, this is kind of like that, but it focuses on device APIs. So starting off here, Android on the left, iOS on the right, camera and microphone. You'll see here that Android supports all these different APIs for recording a stream of your camera or microphone, while on iOS not everything is quite there. And you're going to start to see a pattern emerge here about what's supported on what platforms. Bluetooth and USB, web apps can access that and utilize that on Android. On iOS, not so much. We look at device features like the network type and speed, whether you're online or not. Having the application perform a vibration to indicate to the user that something has happened. What battery percentage do you have left? How much RAM do you have? Android has all that. iOS just has the online state. Native behaviors, Android supports notifications, including push notifications. iOS does not. Operating system, offline storage, they both support IndexedDB, which is the browser's premier offline storage mechanism, key value database store. They both have that. File access allows you to present native UI for selecting a file via the camera, the photo gallery, or the Files app. They both have that, and that's wonderful. Contacts, storage quotas for being able to store things more persistently. Some of that's available on Android, but not iOS. With input, there's good support there for both platforms, including access to the clipboard programmatically. Seamless experience offline, kind of demoed that. Inter-app communications, basically the native share API. You can share text and URLs. Payments, making payments easier with information that's accessible via the browser. Both platforms support that, but not credentials. And then with location and position, that's something that's important to us. As GIS app developers, geolocation is there. You can get the device's current location, as well as some device position and motion APIs available on both. And lastly, screen and output. Android has all these checked, but iOS has none of them checked. Things like virtual and augmented reality, locking the screen orientation, keeping the screen awake with wake lock so that the screen doesn't turn dark and go on the lock screen. Your app stays in the foreground, keeps the screen on. Available on Android, not so much in iOS. So at this point, you might be feeling, wow, Android, that's great. There's so much there available for me to develop an app-like experience, but for iOS, I don't know, I kind of have to think about it. You know, what will my application actually need to use? A number of these APIs are not part of the browser standard. There are attempts of trying to get them there. Some of them are abandoned proposals. Google recently is putting efforts to try to spearhead and add more native APIs to the web with Project Fugu. But some APIs are, even if they're there, they might be limited in some ways, that you need the extra capabilities of the native layer to access and to use. Even with progressive enhancement, you might have hard requirements for a target platform. For us in our application, native APIs that we use with the native layer, because they're not available in the way that we want them in the web layer, the web layer would be like the share API, the native share dialog. The web supports text and URLs, but there's not a way to share a file with another application. Getting the device's manufacturer and model might not be straightforward to get from the user agent string. What about storing data for offline? You're using IndexedDB on the web, and you might want greater persistence durability, that it won't clear out that data if storage on the device gets low. You might want greater querying performance, or to structure your data relationally. You might really want to use SQLite instead. And so we're able to tap into that using the native layer. These things are not available on the web. And so even then, any of these APIs that are shown, for some reason they might not be available or reliable. So that's where hybrid progressive web apps like our application come into play. And so you might not have really heard about that term before, but let's define it. So really what it is it's just a progressive web app, but you add the tooling for Cordova and Capacitor to be able to ship it in the native app stores, and then take advantage of the plugins that you need to access some of those native APIs, like I was explaining what we access in our application. Another way of saying hybrid progressive web app is native progressive web app. This is a term that was, from my understanding, coined by Ionic with Capacitor. Native PWAs, that's what separates them from regular PWAs. They are, if you think about the requirements being served over SSL, the native binary that you download from the store, that has all the code inside of it. So you don't have to worry so much about SSL to say get your files. All the code there, if you've designed it that way, are distributed securely through the App Store, your native app binary. And some of those APIs do work in web views as well. The UX having a native feel and being responsive, that doesn't change. If it's going to work that way in a web browser, well, it's going to work that way in a web view. It loads offline. It uses a different way to load your application files, your HTML, JavaScript, CSS offline than the web does, but that's because they're packaged with the native binary. All those files come with the download of the native app, and so it's going to be there to work offline because it's not going to be pulling these files down over the network. And installable plays into that as well. I mean, you've installed the app from the App Store. And so it really meets that PWA criteria, but the difference is that this is a PWA with native superpowers. It is everything a PWA is, but you can access those native APIs that you need that are not available on the web, and especially with iOS, not having as many things available to it, this becomes really handy to be able to do extra things, to access extra APIs that are not available on the web or the browser engine you're using. Another way of saying a PWA with native superpowers is that it's a PWA with an architectural technical escape hatch. If you find out that requirements change and you need to be able to do something at some point with augmented reality, or you really need to have a SQLite database because, well, you want to do offline, and that works a lot more in a more performant manner because of that, or for other reasons, it allows you to do that without having to throw away your code and start over again. So what I want to do is show you our application. The application's name is Cartograph 1. We're going to launch the app here on iOS, and note that it loads pretty quickly. That's pretty good. Again, this is web technology, so it loads faster than some native apps do. We're going to click the Continue with ArcGIS Identity, and we integrate with ArcGIS Identity. So you can do that. You can sign in, boom, authenticate. So you have one sign-in that you can use for ArcGIS Online or this application. So we sign in, and this is our home screen, and it has a big map on it. Note the blue dot. The blue dot is the current location. We're using geolocation to communicate to the user where they're currently located. So if we zoom out, you're going to see Iowa and Illinois counties that are colored blue. How did they get that way? Well, let's tap on one of them. You'll see that this is an ArcGIS Online web map. So this application supports web maps. It's using the ArcGIS API for JavaScript 3x at this time. But hey, look at the cool stuff that it can do. We're going to switch our map. We're going to go into our map chooser, which is a big list, has a lot of stuff in it. So we're going to scroll down really fast, but note the virtual scroll performs super well. We're going to choose streets. And we're going to zoom in to the red and green that you see there on the map. And what we're looking at are assets. We're looking at, in red, signs, in green, pavement or roads. We look at our layer chooser, we see, yep, red signs, green pavement. So let's tap on the map. When we tap on the map, the items that you tapped on in that area are selected. They turn magenta colored to indicate that that's what's currently selected. Down at the bottom, a list pops up telling you these are the things that are selected. So if we hit show all, we can see here in this list we have pavement and we have signs. You can swipe over, there's a gesture, you can add a task to create some work for an asset, and there you go. How about creating an asset, like creating a pavement? Let's say we're doing asset inventory. We'll click the plus arrow on the top right of the app, and that will open up our create process. Now this is a modal here, it's overlaying the UI underneath, the home screen underneath, and so we'll select pavement, and we'll draw our segment. So we tap on the map, get it on there, we set it, we adjust it a little bit, and we're going to do a terrible job lining that up. And then on the next screen here, we'll set the pavement classification. This is going to be a concrete road, and we'll hit save. Modal dismisses, we navigate to the detail screen, kind of this master detail pattern. So on here, you can view the other details about the asset, you can edit it. One of the things that we'll edit is the shape. So we tap the map and we can kind of straighten it up. Well, we're still not going to do a great job with that. We'll hit save and there you go. You can edit your geometry. We go back to the home screen here and let's mess around with our layers. Let's turn on tasks. Now tasks are work and it's work that needs to be done across all asset types. You're going to see a whole bunch of these on the maps for all sorts of different asset types, not just signs of pavement. But as you pan around, it goes pretty smoothly. That's not really very janky. And so how are we able to draw so many things on the map and still have the map perform really well, especially in 3x, where you might otherwise use SVG type drawing? Well, for our application, only slightly less well known is this, and that is how we do our shape drawing. So here is an example of a map tile of what you would see on the map. And let's explain what comprises that map tile. We're going to start out with this. This is the base map tile from the Esri Streets base map. We then have a custom web tile. This custom web tile layer is on our own custom server. Our server implements a get tile endpoint, and what we do is we do a spatial query against our database for the assets that are within that tile area, and then on the server we create a transparent PNG, and on that transparent PNG we draw our assets. So we take note of what color is it, what shape type is it, what are all the lat longs, and we draw those things out on a transparent PNG. It uses the same extent as the base map tile. Then we have the magenta that you saw on the map when we tapped on the map to select items on the map. This is done client-side using the ArcGIS API for JavaScript. And we only draw up to 100 of those at a time, and so things still stay performing very well, even though we do the client-side drawing there. But when you layer these things on top of one another, you can see that that's what makes up what you see on the screen. So a lot of the stuff that's being drawn on the screen is really just map tiles, and that performs really well, and it has for years, and it allows the map to stay performing really well despite drawing many, many things on the map. So that's wonderful to have that working as well as it does. I want to shift gears here and talk a little bit about the JavaScript API 4x and considerations with Ionic. In our application, we're not using 4x at this time, but we've done some research on it. So the 4x API uses a wonderful thing, WebGL, and WebGL allows you to go into the next generation of mapping. It allows you to do really fancy stuff with 3D, which is kind of amazing. It allows you to draw more things on the map and still maintain a good level of performance. And this is kind of the way forward with mapping. You know, Mapbox has Mapbox GL as well, and there's a lot of potential there. It's amazing what you can do when you kind of escape the DOM in the browser and have really technology that arguably is used for things like video games. So you can do a lot of awesome mapping related things with that. But like anything, there are trade-offs in certain circumstances. It's not specific to Esri, but just using this type of technology, there are some things with Ionic that you might need to be mindful of. One of them is if you're targeting iOS, you need to be conscious about the memory usage. And this is just kind of a generality. On iOS, there is typically less RAM than, say, Android, and the operating system has more aggressive memory management. So if you're developing a single-page web application, when you navigate between screens, it doesn't do a full page reload that totally kills all the memory and starts the application fresh again. One of the nice app-like UX benefits of a single-page app is that it doesn't do the full page reload. It seamlessly, with the client-side router and such, navigates between the screens, and state is managed and maintained across navigations. And that's kind of what SPA architecture brings to the table, which is, Angular, React, and Vue, and has sort of been the case like that for years. So, well, what can you do? So potential solutions, You should be profiling your application's memory and fixing memory leaks. This article here from Nolan Lawson, who used to work on Microsoft Edge, came out very recently, and this, in my opinion, is the best intro to web browser memory leaks that I have ever come across, that I've ever read. In the years that I've been doing memory profiling, this hits the key points and hits it well. You get tips and advice in here that is condensed, and you might not find it elsewhere in some of the more generic articles on memory profiling. I highly recommend checking out this article to give you some tips of how to profile your application for memory leaks. It's pretty awesome. So do profile your app for memory usage and fix memory leaks. The second thing you can do is limit or reuse map view instances. So map views in 4X display a 2D map. And so the less of those you could have, technically, the less memory usage that would take place. So that's one thing to keep in mind. All right, map view WebGL context loss. This is another issue with WebGL and a single page application that doesn't have reloads as you're using the app and navigating between screens. Let's talk about a really simple application that only has two screens, a home screen and a detail screen, and let's say it only has a single map on one of the screens, and let's say that's the home screen. Well, when you navigate from the home screen to the detail screen, the home screen gets destroyed, including the map view. That's by default how it works with client-side routing when you navigate between routes. You navigate back to the home screen, a new map view is created. You navigate to the detail screen, that map view is destroyed. You navigate back to the home screen, a new map view is created. You do this a handful of times, and the next thing you know, you won't have a map at all. You won't get a map when it's trying to create a new map, and that's because it's run out of WebGL context. It results in a context loss. There are a limited number of them. In a load of an application, a load of the browser, and they're unrecoverable without reloading the browser. This can happen when routing between pages like I described, or even using modals with maps in them. So what can you do? One, you can adjust your navigation in your app to try to limit map view instances. Two, you can reuse map view instances. Let's talk about the first. Adjust navigation to limit map view instances. With Ionic, the navigation Ionic by default works a little bit differently than, say, our typical Angular app. Each route in the application, a routed component that makes up the full screen of what you see mostly, that is what's called a page. And an Ionic page, when you navigate to a new Ionic page, so let's look at what that might look like here. Say we click the detail button, the new page slides in. The nice, beautiful transition slides in. What you might not know, and what makes it a little bit different than how other routers might otherwise work, is the home screen is actually still there. It is underneath. The z-indexing is different, and it's actually still there, but it's being covered up. Now, why would they do something like this? Why would they make the Angular router behave a little bit differently? Well, some advantages of this are performance. I mean, you don't have to recreate the home screen from scratch when you go back to it. Like that. It's just there. So the transitions look even better because you're just revealing what was underneath. So it's more efficient. You don't have to recreate it from scratch. It makes the transitions look nicer. But it also supports nonlinear navigation history. So if you think of an application that uses tabs with parallel navigation stacks, think of something like Twitter, the Twitter native app. There are multiple tabs at the bottom, and you can navigate within a tab, and you can change your tab, and you'll be right where you were when you were last on that tab, and you can go back and forth, supporting those parallel navigation histories. But that is inherently incompatible with web browsers and linear navigation history for browser navigation history. They try to keep those things in sync as much as they reasonably can be, but they don't always, line up exactly. So when you have this stacking, you could potentially get map on top of map on top of map on top of map as you're forward navigating through your application and run out of WebGL context. And so what we decided to do was to change our application and re-architect it to embrace a more linear browser-style navigation history. And what we called that was flattening the Ionic navigation stack. And so what this means is that only one Ionic page is in memory and in the DOM when a navigation has completed. The old page gets destroyed. It works more like default, how Angular or other client-side routers you might expect them to work. And so we're going to look at some code samples. However, it's going to be a little bit abridged here, so we're going to kind of sum them up, if you will. So we're going to create a routing service wrapper. Now this is Ionic 5, Angular 9, and TypeScript. But the Angular router, which we would normally just call directly, we're going to wrap that. So the routing service, the provided in root, means that it's a singleton across our whole application. And the constructor will dependency inject the Angular router, Angular's location object, which is sort of like, has some aspects to it of the history API, like window.history and other things, and the Ionic nav controller, which controls some aspects of the Ionic stack, as well as animations when you're navigating to and from screens. So let's create one of those. And then let's talk about adding a forward navigate method to that routing service. So we have the forward navigate method. The last line of the method is what you would normally call directly. It's the Angular router calling navigate on it. However, there is an extra line we're going to add before that. And that is using Ionic's nav controller and calling set direction. And what we say is route. And by route, we mean navigate in the route direction. And what that will mean, what that will end up doing is make it so that when you're forward navigating, you're saying that the page I'm navigating to is now going to be the root page. Anything else that is in the Ionic stack will be destroyed. That means the page that you're leaving is going to be destroyed, and this will be the only page that is left in the DOM. So by doing this, you end up after a navigation is performed, only having a single page in the DOM. Then we also say, yes, go ahead and animate that and have it be a forward navigation animation, because this is a forward navigation, even though we're navigating route. So that's forward navigation. How about navigating back? Now the web browser, using the web browser's back button, if it's a PWA running in the browser, that's going to work as expected, and it's going to take the URL that's in your browser history, and the Angular router is going to look at that URL change and change the page and do the navigation for you. However, as I was displaying in the sample app, we have an in-app back button as well. This is important for iOS as a native app, because you don't have any other way of going back. There's not a hardware back button like there is on Android, so you have the in-app back button. Now Ionic does provide out of the box a component that is the in-app back button. It looks different on iOS and Android to embrace the native platform stylings, but it is geared up toward embracing the Ionic stack with how back navigation works with having multiple pages in the Ionic stack. However, we're saying we're going to embrace browser navigation history and have only one page in the Ionic stack. So what we're doing here is we're creating a custom back button component. And Ionic Framework is free and it's open source. It's on GitHub, and so you can look at the source out there and kind of see how you might style this to make your custom component look pretty much just like the Ionic back button component. So that's what we've done here. In the constructor, we dependency inject our routing service that we were just talking about, that wrapper of the Angular router. And we have an on-click method that'll get called when you click the back button, and it calls routing service.back. So let's take a look at that routing service back method. It's pretty straightforward. Let's talk about the second line first again. The second line is using Angular's location object, and it's using location.back. And what that really is equivalent to in the end running in the web browser is window.history.back, which is more or less like clicking the browser back button. It takes you back in the navigation history. However, right before that, we also want to make sure that the nice Ionic navigation transition to animate the back animation is there and it's present. So that's what we're doing there. We're providing the back animation when you click this back button. On Android, as I was mentioning, there is a hardware back button, the Android back button. And so we want to make sure that that also embraces this style of navigation. So one time in the app, we call this method, we use Ionic's platform object, and we override the back button. And we say, hey, if someone clicks the back button, just call our routing services back method. And so now the in-app back button and the Android back button both work the same way. All right, that's flattening the navigation stack with Ionic. Let's talk about reusing map view instances. Now you might think, wow, reusing map view instances, that's a little bit different than what I'm accustomed to. You know, it might take a miracle to get that to work. But it's really not too bad. We're going to create a map view service. It's also going to be a singleton Angular service in the application, and this is going to maintain a property, map view data list, that will effectively be a pool of map views that are reused in the app. And so this is an array that contains objects that are comprised of an Esri map view for 4x and a note whether it's available to be used or not. So we're going to store them there and track them there and potentially reuse them from there. Let's look at the method to get a map view. This retrieves a map view. If one's not available, it will create one. If there's an existing map view available, it will be retrieved and reused. So in this method, for getting a map view, we try to find an available existing map view from the pool. We look at that is available flag and we check. If I didn't find one, if there was none available, we're going to create one. So we create an Esri map view, we mark it as being not available because the call-in code's going to presumably use it right away, and then we add it to the pool so it's being tracked. In the end, we return that out, that map view. If we did find a map view, we mark it as not being available because it's about to be used, and then we return that out for use. In the client code, this is sort of how it would work. You would call get map view, and besides getting the map view, there's the map itself. You might want to use a different base map, and so we say, if I don't have a map, I'll create one with the base map I want. If I did have a map, then I'll just reconfigure the base map on there. Newer versions of 4x require reusing both the map view container and the map view as well as the map instance itself, or else you could still get those WebGL context loss errors. You can do this for both raster maps and vector maps. Vector maps will produce like a console error about cannot invoke port closed, but I haven't dug into that too much, but it doesn't seem to introduce any negative effects when you see that. So it ends up working for both. When your map component's about to be destroyed, call release map view. Pass in the map view. It will mark that map view as being available now so that later on when the next thing needs to use a map, it is able to find that one as being available and it's able to reuse it. And it works. Now we can escape from the castle and hop on our white horses off into the sunset to live happily ever after. And that's our story, where true love prevails with the ArcGIS API for JavaScript and Ionic progressive web app applications. Let's go back to where we began, and that is with our users. Our users had a need for a phone app, and we were able to give it to them. We were able to provide it to them as an MVP in a short amount of time, quality code, quality technology, and we were able to utilize the modern power of the web platform to be able to provide a beautiful native app-like experience to them. and only have to use a single code base to support all those platforms. By doing that, it allows us to respond better to the needs of our users for bug fixes, for new features. It only needs to be done a single time. That value that's there is amazing. It allows us to be able to provide our users with the tools and features and functionality they need to help elevate the well-being of their community, where things can operate in a way that is such that people in the community can just focus on their lives. And speaking of people in the community, one of the biggest benefactors of helping our users maintain their infrastructure and their communities is helping our families who live in those communities to remain safe, because their roads are safe, the signs are there to help traffic, bridges don't collapse. Maintaining that infrastructure is able to help protect those that we love most. Thanks for watching. I really appreciate your time and spending this hour with me. Check out right there is the GitHub link to the Ionic Esri JavaScript sample app. And I hope you enjoyed it. You can catch me on Twitter if you have any questions or comments or want to chat. And here are my sources for images and other things that I used in this presentation. And I appreciate those. So again, thank you for your time. I hope you enjoyed it. We'll catch you later.